Welcome to Emmelac online tutorial, and for us is this beautiful exponential equation, and here we have 4 raised to the power of x plus x equals 60, and we are asked to find the value of x. Now in cases like this, the most appropriate way to tackle this problem is for us to use the Lambert W function. Okay, since here we have the base and it happens to be an exponent here. Alright, so what is Lambert W function? Now it says that when you have an exponential expression in this form, if you have a e raised to the power of a, okay, now where a is also an exponent of the exponent, it's an exponent of e. Now when you apply the Lambert W function, it equals to what? A. Alright, so our job now is to ensure that we transform this equation into an expression like this. Okay, so let's get started. So from here we have 4 raised to the power of x now plus x equals 60. Okay, the first approach here is let's minus or subtract x from both sides of the equation. I want to subtract x, which means this x will move over to the right hand side, giving us a minus x. We end up having 4 raised to the power of x equals 60, then minus x. Okay, alright, so the next thing is let's divide both sides by 4 raised to the power of x. Okay, now when we divide, now this eliminates this, so we are left with 1 equals 60 minus x all over 4 raised to the power of what? X. And you know, according to the law of indices, if you have 1 raised to the power of x, this is something as saying x raised to the power of what? Raised to the power of minus 1. So we can apply that rule to 4 raised to the power of x. So we can have the whole of this equation now becomes 1 equals 60 minus x, or is it times 4 raised to the power of what? Minus x. Okay, so here we have, here we're going to begin to start the transformation into this kind of exponential expression. So we'll be working only on the left hand side of the equation. Okay, so now first of all, I want to introduce 60 to this exponent here. Alright, so for me to do that, it means, take note of this, let's come over here. If you have a raised to the power of let's say b, okay, and you needed a raised to the power of b plus c, okay, all you just need to do here is to multiply this exponent here by a raised to the power of what? C. And according to the law of indices, as long as they're having the same base, you can add the exponent. Okay, so now applying this rule here to that place, to this one here, we tend to have the 1. Take note, we will multiply that same base to both the right hand side, the left hand side and the right hand side. So this will be 1 times, let me come over here, 1 times 4 raised to the power of 60, then equals the whole of this, 60 minus x, then times 4 raised to the power of minus x times 4 raised to the power of what? 6. Okay, so then applying the law of indices, we have 4 raised to the power of 60 then equals 60 minus x, then 4 raised to the power of minus x, then plus 60. Okay, and you know, in this case like this can also negative x plus 6 is still the same thing as saying 60 minus x, right? So here we can also write this as 60 minus x. Okay, I guess we are getting closer. Now you can see we now have this and this. Now let us see, we will introduce our exponent e. Okay, now let us recall that if you have a variable, let's say x, okay, now this can be e raised to the power of ln x. Okay, now because when an exponent raises a natural log of a variable, then it becomes the answer to that exponent is the variable itself. Okay, so in this case now what we just need to do here, we have that 4 raised to the power of 60 equals 60 minus x. So we need to raise this. Take note, this now becomes the exponent, which is this. So it means we will include e raised to the power of ln. So here we have e raised to the power of ln, okay, then 4 raised to the power of 60 minus x. Okay, alright. Now according to the law of logarithm, if you have a, let's say log a raised to the power of n, now this can also be written as n log a. Okay, so if you apply that here, we end up having 4 raised to the power of 60, then equals 60 minus x, then e raised to the power of 60 minus x, then ln 4. Okay, now you can see here we have 60 minus x, ln 4, and here we also only have 60 minus x. So we can actually, for us to include ln 4 to here, what we just need to do is to multiply both sides of the equation by ln 4. Now this will help us to, include ln 4 to this also. So by doing that, we have 4 raised to the power of 60 times ln 4, then equals, we also multiply this one by ln 4, and this will give us 60 minus x ln 4, then e 60 minus x ln 4. Okay, I guess we've achieved this expression here, which is this. Now 60 minus x ln 4, then 60 minus x ln 4. So at this point now we just need to apply the Lambert W function. Okay, and when we apply that, it just gives us a. Okay, but in this case it will only give us 60 minus x ln 4. So by doing that, let's we have so we apply here 4 raised to the power of 60 ln 4, then we apply the Lambert W function to all of this. Here you have then 60 minus x ln 4, then e raised to the power of 60 minus x ln 4. Okay, I guess, yeah. Okay, so the right hand side now becomes, this is the 4 raised to the power of 60 ln 4, then equals 60 minus x ln 4. Okay, because the whole of this, when after applying the Lambert W function, it gives us this according to this rule. So at this point now, all we just need to do now is to resolve to get x. So first of all, let's divide both sides by ln 4. ln 4, so this eliminates this. Okay, so at this point now, let us just rearrange to make the equation look more organized. So we can say here, this is 60 minus x equals w 4 raised to the power of 60 ln 4, then all over ln 4. Okay, so at this point now, let us let's subtract. Okay, let us subtract 60 from both sides. Or let me just do this way for us for easy access. Now let us take this negative x over to the right hand side, then bring the whole of this expression to the right hand side. Okay, so let me just do indicate it like this. This will give us x, okay? That will be plus positive x, and the whole of this come over to the side, okay? So here we have that there will be 60, then minus, as the whole of this side comes to the left hand side becomes minus. So here we have w, then into 4 raised to the power of 60 ln 4 all over ln 4, then equals, then we have what? X. Okay, so I guess that's all. So you can just multiply to make it a single denominator. Just multiply ln 4 by 60, and we have 60 ln 4, then minus Lambert W function 40 raised to the power of 60 ln 4, then all over ln 4 equals what? X. So finally, our x equals 60 ln 4 minus w 40 60 raised to the power of 60 ln 4, then everything ln 4. Final answer. So if you love what I've just done, kindly ensure that you like my page, subscribe to my YouTube channel, and don't forget to share this wonderful tutorial to everyone. Thank you, and remain blessed. Bye bye.